Welcome guys. Today we'll be continuing making our own game without any environment. So in the last video we actually completed how to write characters over to the screen and the basics of what actually MBR is, how much size do we get, and all those things. Let's get back into that. And this was the last MBR file that we left on. We can test this and see that it runs or not. So it runs. I use Arch, by the way, is on the screen, so it is running. That's nice. Now we need some more basic knowledge, so let's go on a GNU image manipulation program. Here, let me just quickly create a new window. Okay, it's nice. Now we need to write pixels over to our screen for making pong. We do that by interrupt hex 13, that's for graphics interrupt, and the value in AH will be a word, I guess. Yes, it's a word, hex 000H. Okay, so these are the two things that we will be needing. So how does that video memory works? Okay, we will be provided a segment and offset. Remember that the addressing scheme that we use in 16-bit is segment and then offset. So we will be provided a segment and offset memory address, and when we will write something to these memory address, it will be displayed over to the screen. Like we could say at x comma y, draw a pixel colored red, so it would draw at x comma y pixel red. That's it. So first we need a function which draws a color based on some values in the register. Okay, so we will be having a function that will see some specific registers for the x comma y value and draw a white pixel at x comma y. Using this we will be able to draw our two boxes and a ball. Okay, so let's first do that. Before we actually move on, let me also tell you something. How does the addressing works? Okay, so x comma y, how is this converted into the offset from relative 0? So how do we get the index? In the graphics mode, we actually get 320 by 280 screen's resolution. So 320 is for the maximum x, that's the width, and it's the height. So the index of a pixel x comma y is given by y times 320 plus x. Okay, so this is the formula that we use. Why is it the way it is? Let me explain that too. It's quick intuition. Suppose these are the grid, you can say. Okay, so if we are saying 0 x comma 0, means it is in the first line right here, so the offset will be just x. But if I go one line down, then I have to transverse the whole length, and then the offset will be length plus x. If I travel 2 lines down, it will be 2 times L plus x. If I travel 3 times down, so it will be 3L plus x. So length here in this case is 320. The 1 2 the 0 1 2 is the y coordinate, so y times 320 plus x, that's how we get our formula. Okay, so good enough. Let's now get to coding. And before we start coding, let me tell you something. The colors that we are going to use are not going to be RGB. BIOS have some specific values for some specific color. Like red is red, I don't remember the exact thing, but it's something like 12H or something. So we are going to use the color scheme provided by BIOS. Also in real mode, you only get 256 colors, and this is more than enough for almost everything. But yeah, so now let's start finally. Okay, so we need a function draw pixel that will be requires the x comma y values to be preset in. We will be having some registers. Okay, so first let us make this function, and we will be seeing which registers are empty, and then we will be using those empty registers to store the x comma y value. Okay, we move hex A, I guess I'm correct, hex 13 actually, yes, we can move hex 13 into %AX, which sets the AH and AL in such a way that when I call interrupt hex 10, let's go like this. When I call interrupt hex 10, this actually sets up the memory, the video memory, at correct offset. So we now have the video memory. The offset actually is hex A 000 this is the offset, or I have to look this offset up. I don't remember exactly. It can be either one of those, so I have to look it up. Okay, so I looked it up, and this is the correct one. This isn't the correct one, so let's remove this. Now we need to implement our basic maths. Okay, so the index formula was y times 320 plus x. Okay, now this is correct, obviously. Let's go, and first we need to store this thing into address registers. Okay, so what are address registers? Let's go here. BX, BP, SI and DI are the only allowed registers for memory address storage. So let's store the address, the literal address. So hex A000 into %px. It's nice, I guess. Then we need to first get the y times 320 plus x, so we can move ax, we can move the x value, so we need some buffer register. So it x and y are words. Okay, so wait a minute. Okay, we need to decide the registers in which we will be having x and y. Okay, so cx is the thing that we could use. Dx and cx is the thing that we are going to use. So dx contains x and cx contains y. So first we have to, okay, so move the literal 320 into %ax, because we need to multiply. Then we will be saying x and cx contains the y, so multiply cx, I guess, %cx. So it's now correct. Ax contains the result. Now we can go add the value in dx in ax. So ax contains y times 320 plus x. Now okay, that is nice. So once we have got this, we can just move this, like we can move in this specific memory address the value. So it's like bx offset. The offset should be in address registers, right? So what are the address registers? We have SIDI, BX, BP. So let's go move the value in AX to DI, I guess. DI would work. Is it empty? Yes, it is. So now I could say move the value at offset BX, at segment BX offset DI into %AL. Now moving into %AL means it's a white pixel. There is one more thing that I'm not sure about. I'm not sure about this thing right here. it is hindering me so very much. So what I'm going to do is I'm going to move the literal this thing into %ax and then move the value from %ax to %bx. It is just a safety move that I played here. It's just for safety because I just realized that directly setting things like this can corrupt. So just a safety, safety, safety. Okay, now let's go and %target and this thing. Now let's run this, and I didn't saw anything. Why? Because freaking we didn't call this thing drop it. After this it should return, I guess. After many Gemini and ChatGPT prompt, I finally got that to work. It took me around 2 hours, but it's now working, and I cut it the video because I don't want to show all that active stuff. But this is what currently I have. Even Gemini and ChatGPT are producing some horrendous bugs, as you could see. That left and right pattern are at the same place. The colors are changing like crazy. So I will be working on this thing, and we will be completing this in the next video, cause it took really long to just get to this point. So yeah, I'll be seeing you in the next video.